So let's look at an example of using that, the order operations in reverse order that we were talking about, using PEMDAS backwards essentially. Now, in an example of solving an algebraic equation. And so, again, our first rule is that the two sides have to be as simplified as possible before we even start our rule of whatever's happening to the variable, you do the opposite. So we need to simplify both sides here. And basically on this side, what we need to do is just combine like terms. And so we talked about that in the last section of like terms mean that it is the same variable to the same power. Okay? And so a 5x and a 2x simplify over here. Those combine, we have 5 of these things and 2 of these things. So altogether we have 7 of those same things. They don't combine. You don't add desks and get desks squared. You have 5 desks and 2 desks. That's 7 desks. Okay? We have a 3 and a -1, or 3 minus 1, and so that's a positive 2. Okay? So that's this side simplified. Over here we need to distribute through these parentheses, and so we're going to get a 2 times x, and we're going to get a 2 times a -1, so that's -2. And then we have this plus 2 outside the parentheses, and so because it's outside the parentheses, it does not get multiplied by that 2 right there. Okay? The 2 stops at the end of the parentheses in terms of the distribution going on there. So it's just a plus 2 at the end. And so we can simplify that side one more time here and get the 2x to stay, and then the -2 and the positive 2 actually drop each other out. They add up to 0, and so they just kind of go away. We don't say plus 0. We don't need that. Now, we finally have both sides simplified, and so now we start the process of whatever's happening to the variable, you do the opposite. Now again, we're talking about our assumption here that we're trying to get all the variables on one side, numbers on the other. And so because there's x's on both sides, we need to get the x's all on one side. And typically it's easiest if you get them to the side that has more of them. So there's 7 of them over here, only 2 over there, and so we're going to get the 2x over to this side. And so because the 2x is a positive 2x here, I'm going to subtract 2x on that side, and we're going to subtract 2x on this side. And so what that's going to allow for this to happen is 7x minus 2x is 5x. Okay? The 2x minus 2x is going to drop out. I'm sorry, I'm getting ahead of myself here. The 5x here, the plus 2 is still here. And then this drops out to 0. Now we do write that 0 because there's nothing else left on that side of the equation. We don't want to lose our equal sign. So now there's a positive 2 here. Again, we're doing the order of operations backwards, and so this 2 is being added first before I get to this 5 being multiplied. I do addition first, so I'm going to subtract 2 here, subtract 2 here, because whatever I do to one side of the equation, I must do to the other side. And so that leaves me with a 5x on this side. 0 minus 2 is a -2. Now what's happening to that variable? It's being multiplied. There's an unwritten multiplication symbol there. It's being multiplied by 5. So I'm going to do the opposite. I'm going to divide by 5. Because I introduced that 5 new to this side, I have to do it to both sides or my equation will be out of balance. And so these 5's cancel. I end up with just x by itself, and I can't really do anything with that side to simplify it, and so it just stays a -2/5 on that side. And so our answer is -2/5. And it's okay to have fractional answers. Fractions are numbers too. Don't be prejudiced against fractions. They're numbers too, and so that's what our answer ends up being. And the reason why you should never miss an algebra problem, ever, you should never ever miss an algebra problem, is because you can take that -2/5 and plug it in to our original equation. And it would be easiest if we plugged it into the simplified version of that equation. You could plug it into the original, just more complicated, but we could plug it in right here and solve that and check it to make sure that it does work. And actually maybe it'd be even easier to plug it in right here, assuming that we know we've done our steps correctly to get there. And so if we plug in that -2/5 right there, we would have 5 times a -2/5 for that x right there, plus 2. Does that equal 0 is what we're checking. Well, this 5 is over 1, unwritten 1 there, and the 5's cancel, and so we end up with a -2 here over 1. We don't write that 1. Plus 2 equals 0. So is -2 plus 2 0? Yes, it is. And so our answer checks, and so we know it's correct. Okay, but you should never miss an algebra problem because you can always check your answer. Why do people miss algebra problems then? Because they're too lazy to go back and check and turn it in and plug it in to see if it works. All right, so we'll look at some more examples and some quiz questions based on this, and hopefully get you to where you can solve these equations.